Hello everyone, we are Team Flip Flops and we are representing VNIT Nagpur and my team includes Diplesh Mankape who is our team leader, Vishwesh Pillai, Ayush Wadia, Yash Mantri, Shraddha Bhagwat and Amit Mumari. So let's dive into our problem statement. So our problem statement is to utilize drone technology to address insufficient medical support for villages in remote hilly areas. And the organization presenting this is National Institute of Design Madhya Pradesh. So, first I will talk about the motivation behind this problem statement. So, majority of the rural population consists of women and old people who cannot travel, and there is, of course, lesser connectivity in hilly areas, so drones are required. Now, inaccessibility of health service in we have seen in the COVID times there was inaccessibility of health services in the metro cities itself. So in the hilly areas, the situation was much worse. So we aim to improve upon these things. So this is so our solution is a three simple consist of three simple stages. So in the first step, there would be a vehicle which would collect medicines and testing kits from the nearby pharmacies. Now this vehicle would contain drones as well as testing kits and pharmacies. Now this vehicle will move to the ideal road point. This road point would have the maximum coverage for multiple villages, and this optimal point would be found out using our artificial intelligence algorithm. Now, after doing this, there would be trained engineers who would be taught how to use drones. Now these trained engineers would be able to guide the drones from through the most optimal route, and this optimal route would be found out using a genetic algorithm or the artificial intelligence algorithm. So this is a three-step process. Uh, Now methodology of our solution. So the patient can easily consult with the doctor and doctors can prescribe medicine and the test can be performed with the help of drones. We are using April tags to guide the drones to their landing and takeoff positions. Now, while dealing with drones, there is a one limit that the distance traveled by drone cannot be more than 25 kilometers. So we are aiming to find the most optimal route for the drone as well as the ideal point for the vehicle, so that this process should be most optimal and we get a maximum efficiency from our drones. We are also using genetic algorithm for calculating our flight paths and clustering to find the optimal vehicle position in order to minimize the total number of drones used and also to reduce the battery cost. So this was a methodology. Now this is one sample prototype of our end result. So in the middle, this would be our warehouse, or this would be our hub where there would be drones and pharmacy and testing kits, and all the location can be considered as the nearby villages. So whenever there would be requirement in any villages, so we can deploy any drone to that village containing all the medical essentials. So this was a prototype, and this is the genetic algorithm which we would be using in our code in our solution. So in genetic algorithm, basically at in each generation the children are generated. In the layman terms, I would explain genetic algorithm. So in each generation the children are generated, and the children with the most efficiency is taken to the next generation, and this children becomes its parent. So this is the genetic algorithm. So this was our proposed solution for the problem statement of utilization of drone technology to address insufficient medical support for villages in remote hilly areas. Hope you liked our presentation. Thank you.